SIMATIC PCS 7 version 9. This is the title of our next presentation. We can bring digitalization down to the field with PROFINET and hardware innovations. What that all is about, and in detail, this will be presented to you by my colleague, the Portfolio Marketing Manager for Automation and Engineering, Manuel Keldenich. Please welcome him up on stage.
Welcome also from my side. I guess you all have heard a lot of digitalization here all over the booth at the Siemens courtyard. And I'm going to talk about digitalization in the process industry and how we can bring digitalization down to the field level. Because we're coming from the mind sphere, we have an enterprise asset management system, and we have a DCS, a distributed control system, which is needed to run a process plant, basically. So when I'm talking about this, I think we have to start with the challenges in the process industry. And one challenge is highest availability of the plant. Because you can imagine an oil rig, for example, which is producing and producing, and you can generate value or economical benefits only the time that this plant is up and running. If you have a stop of production, this can easily cost you more than 10 million euros each and every day. So availability is key in process industries. Another topic is investment protection, because when you engineer a process plant, you have in mind that the thing that you are engineering right now, this plant, will be up and running for more than 30 years or even longer. So you have to already consider what's coming in the future. And then talking about the plant runtime of more than 30 years, it is clear that this plant cannot run for 30 years and then sometimes it's over. So it has to be modernized, extended from time to time. So at least the data basis is changing each and every day because you have new equipment, etc., etc. But how to overcome these challenges? Guess what? Digitalization is the answer. And I'm talking about digitalization down to the field level. Means where you have all this little equipment like pumps, flow meters, etc. And PROFINET, an industrial Ethernet communication standard, is the basis for us that we use to bring digitalization down to the field level. Because PROFINET is enabling to communicate nearly in real time. And what's really important for us is, in regard to modernization projects, that it is really flexible. It has scalable architectures, and it gives us a lot of opportunity when modernizing a plant, for example. So we have developed new hardware for our new version 9 of the distributed control system, SIMATIC PCS 7. We have a new remote I/O for highest availability. We have a new compact field unit that makes the closing from the control cabinet to the field level. And for sure, we also have some software innovations because we're talking about a completely new version. Starting with our new remote I/O, the SIMATIC ET200 SPHA. First of all, we reduced its width. Means 50% smaller, and in the end, we can connect much more modules from 12 to 65 right now. That means that within one standard cabinet, we can realize much more I/Os. I/Os are the input-output signals that you need for the communication from the control system down to the field. Another real big benefit to reduce space is that with the integrated terminal blocks, we do not need the MTAs within the field, which are basically needed to transfer and to connect all the cablings, all the wirings down to the field level, but which take a lot of space. So we have a modular structure, we save space, and a lot of cables. We already had our first project that with this approach, with the new remote I/O, we could save up to 60 or 70% of the copper cables that run into the field and come back, which means in the end, this is really a lot of value for our customers. Another use case that I would like to describe is change and run. Due to the redundant PROFINET interface, which you can see here with the two green lines, we are able to exchange modules in runtime when there's an error occurring without having a downtime. Means shutting down the system and it is not producing anymore for the time the repair needs. So we do not need different equipment or mechanics. We have a push-in technology, so we just take out the module, exchange it to a new one. The error is fixed without downtime. And our customers benefit in this case from the downtime avoided, no risk for errors, etc. A third use case is that we can standardize the control cabinet assembly. Means we have uniform terminal blocks and we have a fixed wiring, so we can standardize the cabinets, save a lot of space, and thus lower the costs for planning, installation, commissioning, and also the time and the effort for the so-called factory acceptance test, which you have to do to make sure that it is working right now, that the things that you have engineered are really working in the field. And in the end, you have a much faster commissioning, troubleshooting, and save enormous time. To sum it up, one topic is that we can also use it in harsh environments in a temperature range of -40 to +70 degrees, which is really beneficial when you think about an oil rig, for example, which is in the Nordic Sea, and where high temperature differences are. It's up to X zone 2. We have a lot more connections that we can provide within the existing space that is limited, and cost savings is obvious. I also mentioned the second hardware innovation based on PROFINET, which is our compact field unit. It enables us to realize a completely decentralized approach. What you can see here is that in the field you have a flow meter, which is connected via Profibus PR to our compact field unit, and the compact field unit is connected via PROFINET, means industrial Ethernet, to the control cabinet. We can mount it directly in the field, and with this approach, we need less cables, a lot less cables, and plant extensions are much easier because we are not limited to the control room and the space we have for the control room and the control cabinet, etc. We can mount it directly in the field, and it's a box which has just this size, like a card box for shoes, for example. So we have less effort for the installation, for the planning, and for the documentation too. Now showing a short use case on device integration. When, for example, there's an error occurring at the flow meter in the field, we have to exchange it. We take it out, insert a new one, make the wiring from the field device to the compact field unit, and the compact field unit is using the automatic addressing functionalities of PROFINET, makes an initialization, and gives a short hint to the software, the control system above. So in the end, we call it plug and produce, which means it's as simple as connecting a printer to your computer. So now we have time savings in regard to this process from more than 1 hour or half an hour minimum nowadays to less than 1 minute in the future. And the benefits are that you have much more flexibility in regard to plant modernization and extension projects. You have enormous time savings and cost savings for sure. Well, I already mentioned it in the beginning. We do not have innovative hardware. We also have improved our software solutions, which are a major part of the distributed control system. One of that is our process device manager, which is needed for the initializing and the integration of process devices into the distributed control system, so that it recognizes that they speak the same language, basically. And with the new version based on PROFINET, we can lever the full potential of the CFU because they are talking together, talking with each other. Another solution regarding recipe engineering is mostly important for pharmaceutical or for food and beverage industries, because we can now import recipe data and separate the engineering workflows for equipment modeling and the recipe creation. In the past, it was a joint approach, and now we can separate this and roll it out on different plants from one vendor, so it's much easier. With our SIMATIC PCS 7 maintenance station, we have the opportunities now to really have a vertical data integration from the control room via the control cabinets down to the field level where the field operator is exchanging devices, for example. So the data and the documentation are always consistent and up to date. Last but not least, with our SIMATIC management console, we provide opportunities to our customers to manage and to have a look at the existing status of their hardware and software installation within the field, manage it, and in combination with our customer support database, we can also give them suggestions how to improve their installed base, use, for example, more energy efficient devices, etc. So our customers benefit basically from better informed decisions. They have less workload. The error potential is much lower than it was before. And they save a lot of time. And what's really important, the documentation is always up to date. Because you can imagine, for example, in the pharmaceutical industry, the legal authorities like the TÜV might ask you for the documentation and you do not have to search for it. You have it there just by press of a button. So you can always ensure regulatory compliance. And all that taking into combination, the PROFINET approach, the decentralized approach with our compact field unit and the new remote I/O is why we call it room for new perspectives due to space gatherings and more flexibility. At a glance, we have the more flexibility. We have the usage of PROFINET, which is the future also for the process industries. We have enormous cost savings and improve the profitability of our customers with this approach. If you want to learn more about that, please feel free to join us at the courtyard beside or behind, from this point of view, the Digital Enterprise courtyard, and we are glad to answer your questions on that. Thank you very much and have a nice evening or a nice day at the Hanover Fair. Thank you.
Thank you very much, Martin.